Transmission of sound. Sound is transmitted in the form of longitudinal waves. Wave motion is disturbance, which travels in a material medium and is due to repeated motion of the particles of the medium about their mean position, the motion being handed over from one particle to the next. Wave motion is of two types. 1. Transverse wave motion. 2. Longitudinal wave motion. Transverse wave motion. Transverse wave motion is that in which the individual particles of the medium vibrate in a direction at right angles to the direction of propagation of the wave. Example: wave produced in water when a stone falls in it. Longitudinal wave motion. Longitudinal wave motion is a wave motion in which the individual particles of the medium vibrate back and forth along the direction of propagation of wave. Acoustics of buildings. Acoustics is the characteristics of a building in relation to sound. Inside a building, sounds are reflected repeatedly by walls, ceiling, and objects in it. This repeated reflection and persistence of sound, even after the source has stopped producing the sound, is called a reverberation. The time taken for the intensity of the sound to be reduced to 1/1,000,000th of its initial value is called reverberation time. To have acoustical effect, reverberation time should be 0.5 second for speech and 2 to 2.5 seconds for music. Characteristics of wave motion. Each particle takes energy from its preceding particle and transfers it to the next particle, and so on. It is only the energy which is being transferred, not the particles themselves. All the waves travel with the same speed in the same medium. Velocity of the waves is different from the velocity of the particles. The characteristics of waves. Amplitude is the maximum displacement of the vibrating particle from its mean position. The amplitude shows the amount of energy carried by the wave. The larger the amplitude, the greater is the energy the wave carries. Wavelength is the distance between two successive crests or troughs in a transverse wave. Similarly, it is the distance between the two successive compressions or rarefactions in a longitudinal wave. The wavelength is measured in meters. The symbol of wavelength is lambda. Frequency is the number of vibrations made by the vibrating body in 1 second. Frequency is measured in Hertz. It is represented by the symbol Nu. N. Time period is the time taken by the vibrating particle to complete one vibration. It is represented by T. 1 by T is equal to n. Wave velocity is the distance traveled by the wave in unit interval of time, which is equal to the product of wavelength and frequency. It is represented by v. Relationship between wave velocity, frequency, and wavelength. Wave velocity v is equal to distance traveled by time taken. If t is the time period, E lambda is the wavelength. V is equal to E lambda by t, but 1 by t is equal to n frequency. V is equal to E lambda n. Wave velocity is equal to wavelength frequency. Difference between transverse wave and longitudinal wave. 1. Transverse wave particles of the medium vibrate in a direction perpendicular to the direction of propagation of the wave. Longitudinal wave particles of the medium vibrate parallel to direction of propagation of the wave. 2. Transverse wave crests and troughs are the characteristics of transverse wave. Longitudinal wave compressions and rarefactions are the characteristics of longitudinal wave. 3. Transverse wave occurs in solids and liquids. Longitudinal wave occurs in solids, liquids, and gases. Origin of sound. For sound to be heard, 3 conditions must be fulfilled. 1. There must be a vibration body. That is, there must be a source producing sound. 2. There must be a medium to carry away sound from one position to the other. 3. There must be a recording instrument, say a ear or microphone, to record sound. If any of the 3 conditions is not satisfied, there will be no sound. Sound is a form of energy. Sound is produced whenever an object vibrates. Sound travels in the form of waves. We can hear the sounds of vibrating objects with the frequency range of 20 Hertz to 20,000 Hertz, which is known as the audible range of frequency. Sound waves of frequency more than 20,000 Hertz, ultrasonic sound waves, and less than 20 Hertz, infrasonic sound waves, cannot be heard by us. It needs material medium to travel. The velocity of sound in air is 330 meters per second. Wave is a kind of periodic disturbance which travels through a medium due to the repeated vibration of the particles of the medium.